All right. Hey, everyone. I'm Daniel Friedman. I work on the Polymer library. And for the next 15 minutes, we're going to go over how to make your Polymer elements ready to ship into production through testing methodology and infrastructure. Now, you may be wondering, what are production-ready elements? And in essence, production-ready elements are reusable. They have great documentation, they have understandable code, and comprehensive testing. But it's a fair question to ask, why should I care about reusable elements? I always make my apps from scratch, and that works well for me. But the simple fact of the matter is, reusable elements lower the cost of making your app. If you can standardize on a set of robust, highly reusable elements when building your application, you will improve productivity by only working on the parts specific to your app. And here's a real-life example. Google uses Polymer in over 500 applications. Some are public, some are not, but all of them have to pass a high bar of quality for their users. And in these 500 applications, Google wants elements to have the same behavior. Buttons, checkboxes, dialogues, sliders, everything should be consistent. And this means that Google wants to reuse elements across applications so that the application developers don't have to duplicate all the same behaviors. And in order to meet the needs of Google and other customers, Polymer has to maintain over 100 elements across 3 GitHub organizations with an additional copy inside of Google's internal source control system. And to make sure that these reusable elements actually keep their promise to save the application developer time, they have to be highly tested, have great documentation, and contain understandable code. And that means they need to be production ready. Well, by this point, you're probably thinking, that sounds great, but how do I make my elements production ready? Well, remember this slide? It isn't by accident that Polymer has so many users inside of Google. We learned how to make our elements production ready, and we know the tools to use that will make your elements production ready as well. And whether you're building one element that you want to share with others, or you're part of a large company maintaining a huge set of elements used across tons of apps, there are lots of tools at your disposal to make sure every commit is production quality. And since there's so much to talk about today, I've condensed it for you into this easy how-to guide. And as a part of this guide, we'll be taking a look at Paper Checkbox. That link at the bottom will take you to the repository, so you can get a good look at the tools we use on our production-ready elements. And the main focus of this guide is really about testing, and in particular, these 3 areas of testing: linting, unit testing, and continuous integration. Let's take these one by one and discuss why they're important. How about we start with linting? Linting tools help you spot easy errors like misspelling a variable name or forgetting a comma. They can be integrated into your editor to help you spot mistakes before you even start your tests. And the first tool I want to talk about is eslint. So eslint is really an industry standard. It's extremely configurable, has a broad plugin system, and most importantly, it's compatible with our use of HTML imports by the way of the HTML plugin. Now, you can configure eslint to enforce all manner of coding style choices like braces, quotes, logging, capitalization, but this is all you need to run eslint on Polymer elements. So there's a lot here. Why don't we break this down? First, we extend the recommended styling guide made by eslint. This styling guide has just enough to catch syntax errors and generally bad styling, but it won't force you into any particularly opinionated style. Next, we tell eslint that we expect this code to run in the browser. So now browser globals like document and window won't cause errors when you lint. Then we enable the HTML plugin so that elements written in our default Polymer style with DOM module and inline scripts will be checked correctly. And finally, we tell eslint about the Polymer global itself for use when we register our element. And that's it. Pretty simple, right? Now you can turn on eslint when writing Polymer code and catch a wide swath of errors before you even start your tests. But let's move on to Polylint. Polylint is a linting tool that the Polymer team has created that catches Polymer element-specific mistakes that a tool like eslint is not really designed to do. Polylint checks that all of your dependencies are imported, that your properties are defined correctly, and that the syntax is correct in your data binding expressions. With eslint and polylint together, you don't have to write a whole set of unit tests, but you can be still production ready. All right, that's everything about linting. Because now we can move on to unit testing. So unit testing is really what most people think about when they say testing, where you write scenarios for your code, where you know the inputs and can test that the outputs match the expectations of your algorithms and processes. And typically in web development, unit testing involves one or more of these libraries: Mocha, a test framework; Chai, an assertion library; and Synon.js, a mocking and spying library. This combination works well for thousands of projects in the web ecosystem, and we on the Polymer team like them as well. But we were faced with a question. How do we make Mocha, Chai, and Synon.js work the best with web components and Polymer? We tried a number of tools out there, but in the end, we decided that we really needed to make our own. And we did just that and made Web Component Tester, or WCT for short. Now, we had a few requirements for WCT that no other tool really seemed to give us. Obviously, the first requirement was that Mocha, Chai, and Synon.js should just be loaded by default. We also add a few testing helpers that I'll get into a little bit later. Another requirement is that we wanted to write our tests the same way we write our elements, with HTML and JavaScript together. In addition, we wanted to test our elements using the same dependency mechanism that we have for writing our elements, which is HTML imports. And finally, we wanted to be able to run our tests both in the browser and via command line tool. So why don't we take a little deep dive and see how WCT works. Here is the test runner page for our paper checkbox element. And here is where we specify the suites we want to run. You can see that we actually specify the same suite twice, albeit slightly differently. The second line means that we want to run that suite with native shadow DOM enabled. And this is to make sure that paper checkbox works correctly both in the polyfill and native shadow DOM implementations. All right, why don't we take a look at what that basic suite contains. But first, we have to load our dependencies. We load the web components polyfills, WCT. We load mock interactions, which is a testing helper I'll get to in a little bit. And finally, we load paper checkbox. And here we go. A little test from the paper checkbox suite. We have Mocha's suite and test functions. Here we have a Chai assertion with a checkbox being checked. And finally, we have these two parts that probably don't look very familiar, but they're part of the testing helpers that we load with WCT. The first one, test-fixture, is an element wrapper that integrates with Mocha suites to easily produce and remove testing elements from the document. You can put your complicated testing, like this example from paper checkbox, inside of a test-fixture element to create the elements, then you can test them, and automatically at the end of the test, they'll be removed from the page. Mock interactions is another helper that lets you easily mock user input with an understandable API. You can mock mouse events, touch events, keyboard events, focus changes, and you can use it whenever you have a test that requires user input to modify properties or fire an event. Now, the last WCT add-on I want to talk about is the accessibility suite. By using Chrome's accessibility developer tools, you can automatically test some baseline accessibility for your element, like making sure your labels are readable for those with color vision deficiency, or that the ARIA attributes are set correctly for screen readers. Now, you can use the accessibility suite by specifying a test fixture and calling the A11y suite function with that test fixture, and this will do all the work for you and give you a detailed report in your testing. Now, remember that I said you can use WCT via the command line? The WCT command will use Selenium to automatically open all the browsers on your machine, run the tests, and report the results back. In addition, if you use the Sauce Labs plugin, which I'll mention a little bit later, you can test all of your supported browsers and operating systems from one command. All right, that was a lot of stuff, but we can mark unit testing complete, because now we can talk about continuous integration. Continuous integration takes all the linting and unit testing tools that we just talked about and runs them on every commit to your code repository automatically. There are a lot of options out there when it comes to continuous integration services, and I really don't have time to go into all of them. But I can talk about Travis CI, which the Polymer team uses for a few simple reasons. First and foremost, Travis CI easily integrates with GitHub. There's no complicated strings to copy back and forth or keys to remember. Just a button on the Travis CI settings page, and testing is now enabled for your repository. Additionally, Travis is free for open source. And this makes it an easy choice if you publish your element code to GitHub like we do on the Polymer team. All right, now that I've told you about Travis CI, how about I show you how to configure it for your element? Here is a sample Travis configuration for a Polymer element that combines all of our testing. We use this part here to make sure our VM is up to date and can run Node.js. Next, we install Firefox and Chrome. Then we install Bower, Web Component Tester, eslint, and Polylint. We install our Bower dependencies, run our linters, and assuming the linting was successful, we tell Travis to spin up the display server and run WCT. If anything fails testing, Travis will mark the run as failed and send an email to the author of the commit. Now, with Travis CI watching, you can be sure no untested code ever hits the repository. But there's one last trick with Travis CI and WCT. Remember I mentioned Sauce Labs earlier. Travis CI can keep an encrypted copy of your Sauce Labs credentials and give those to WCT to test all of your supported browsers on every commit. All right, we're done with continuous integration. Now, that was a lot of stuff to cover, but you all remember it, right? Well, neither do I. Setting up a robust testing toolchain is super complicated. There's a bunch of tools and configurations spread out across 100 elements, and we on the Polymer team feel that pain because we have to maintain over 100 elements and the tools to make those elements production ready. So we made sure that the testing process is just as reusable as our elements. Refer back to our example element, paper checkbox. 90% of the testing configuration in that element is a copy and paste into your own element. And now your element can reuse all the same linting, unit testing, and continuous integration tools that we use in our elements. And now your elements will be just as production ready and reusable as the Polymer team's elements. And when your elements are reusable, that saves you time and money on building your applications. All right, that's it from me. If you want to learn more about improving your elements, come find me at the after party. Thanks, everyone, and have a great time at the rest of the summit.